Hi everyone, welcome back. Today we are solving find unique binary string. So the problem states that given an array of strings nums containing n unique binary strings, each digit of length n, we want to return a binary string of length n that does not appear in nums. And if there are multiple answers, we may return any of them. So if we look at some of these examples, 1, 1 does not appear in this list, so we can return that, and we can also return 0, 0. In example 2, 1, 1 doesn't appear either, so we can return that, or we can return 1, 0. And in the last example, 101 doesn't appear in nums, so we can return this, or we can also return 3 zeros, 0, 1, 0, 100, or 1, 1, 0. So now that we have seen some examples, let's get to how we can solve this problem. So I think a pretty common way to solve this problem is we can just use the standard backtracking, and the chart will look something like this. So at every character, we can choose to add a 0 or add a 1. So you may think that the time complexity is 2 to the nth power, but since the number of characters in each string is equal to the length of the array, so realistically, we will never need to try every single output. So for example, when the length of the list is 3, there will only be 3 characters. So if you think about it, at the very most, it will go through the first 3, and if they're all in the list, the fourth one will for sure not be in the list. So that's why we'll never go over all of it. So instead, the time complexity will be n squared. And there's actually a more efficient way to solve this problem, and it's actually simpler to explain, so I'll go over that way right now. So the better way to solve this problem is we can follow Cantor's diagonal argument. If you're not familiar with this, feel free to look it up first, but basically what we can do is initialize result to an empty string, and then we will iterate through the input array, and we can view it as like a set of rows by column, and we want to pay attention to the diagonal. So this will be like the first string in the array, second string in the array, third string in the array, and basically whatever is in the diagonal, we add the opposite to the resulting string. Which just means if it's a 0, we add 1. If it's a 1, then we add 0. And finally, we will return result, and this result would be one of the missing strings that is not in the combination. So let's go over this example real quick. At 0, 0, we would just add 0 to do the opposite. And at row 1, column 1, we add the opposite, so 0. And then at row 2, column 2, we will add 0 because it's the opposite of 1. And as we can see, that is not in the list, so we can just return this one. And the time complexity would be O of n, where n is the number of strings, because we have to iterate through this list. And the space complexity would be O of 1, because we are not using any extra space. So now let's get to the coding part. So first, we will set up the result as an empty string. And for I in range, length of nums, so we'll set the for loop, and we will look at what nums of I at I is, because we're going down diagonally. So at nums of I, and we just add 1 to result if current is 0, and if it's not 0, it's gotta be 1. So we just add 0 if current is 1. So else we add 0 if current is 1. And at the end, we can just return result. All right, let's see if it works. Okay, perfect. Thank you for watching. Hope this was helpful. If you have any other questions or comments, feel free to leave down in the comment section. And I hope to see you all again soon.